Now let's talk about what happens to trig functions when we try to take the limits at infinity. First of all, I want to point out that trig functions do not have a limit at infinity that exists on their own. The limit as x goes to infinity of, say, let's pick one, let's pick cosine, is what? Well, the answer is it does not exist. Why? Because the cosine is periodic, and no matter how far out you get, it's going to keep oscillating between 1 and -1 without approximating any one value. The same thing with the rest of the trig functions. The only way to get a trig function to converge to a limit is if it is part of a composite function. So let's look at the limit as x goes to infinity of sine of x. Well, it's going to oscillate between -1 and 1. It's never going to converge to a point. So this answer is it does not exist. Move on. Why? Because it oscillates. You can say it oscillates, or you can say it's periodic. I don't care which one you use. But now let's look at the limit as x goes to infinity of sine x over x. Well, this, you can tell from the picture it does have a limit. Let's look at sine of x. We're going to use a squeeze theorem here. I know sine of x is bounded between 1 and -1. Now, for x is positive infinity, that's the limit we're looking at, this one over here. So I know x is positive. So I'm now going to divide this whole thing through by x. So 1 over x is less than or equal to sine of x over x, and that's less than or equal to 1 over x. Now I know the limit as x approaches infinity of 1 over x is 0, and the limit as x approaches infinity of -1 over x is also 0. Therefore, by the squeeze theorem, the limit as x approaches infinity of sine of x over x is equal to 1. And usually, especially with sine or cosine, you do have to use the squeeze theorem.